Welcome to the Network Plus Prepcast, your dedicated audio companion for mastering every objective on the CompTIA Network Plus certification exam. This series is produced by baremetalcyber.com. Automating the cloud explores a transformational approach to managing infrastructure by using code to define and automate deployment, configuration, and updates. Infrastructure as code, often abbreviated as IAC, replaces manual processes with automation scripts that ensure consistency and repeatability. Instead of logging into devices and configuring them by hand, administrators write code that tells automation tools how to build and manage the environment. This method is widely used in cloud computing and DevOps practices where speed, scalability, and reliability are critical. The Network Plus exam includes questions on automation and cloud integration, and infrastructure as code is a core part of those objectives. You may encounter scenario-based questions that ask you to identify the benefits of IAC, match specific tools to their use cases, or recognize how configuration files interact with deployment workflows. Understanding the purpose, advantages, and practical uses of infrastructure as code will help you answer emerging technology questions with accuracy and confidence. Infrastructure as code allows network and system infrastructure to be defined through configuration files and scripts rather than through manual setup. These files describe the desired state of the environment, including virtual machines, storage volumes, network interfaces, and more. When run through an automation tool, the system reads these definitions and provisions the infrastructure automatically. This eliminates the guesswork and variation that comes with configuring systems manually, providing an efficient and predictable approach to managing environments. There are two main approaches to writing infrastructure as code: declarative and imperative. A declarative approach focuses on describing the desired end state of the infrastructure. The tool determines how to reach that state from the current configuration. An imperative approach, on the other hand, defines specific steps that must be executed in sequence to reach the final configuration. Some tools support both approaches, but choosing the right method depends on the task, the team's experience, and the tool's capabilities. Knowing the difference between these approaches helps clarify how changes are implemented and maintained. Several common tools and platforms are used to implement infrastructure as code in various environments. Terraform is a popular multi-code tool that can manage infrastructure across different providers such as AWS, Azure, and Google Cloud. Ansible focuses on configuration management and can automate repetitive tasks on servers and network devices. CloudFormation is an Amazon Web Services tool used to define and provision AWS infrastructure using template files. These tools differ in syntax and capabilities, but they all support the core goal of automating infrastructure provisioning and management. The benefits of using infrastructure as code are substantial. First, it accelerates the deployment process, allowing teams to spin up complete environments in minutes rather than hours or days. Second, it reduces human error by eliminating the need for manual typing and configuration, which can introduce inconsistencies. Third, it supports version control by storing all configuration files in code repository. This allows teams to track changes over time, roll back to previous configurations if needed, and maintain an auditable history of infrastructure changes. In cloud environments, infrastructure as code automates the creation of virtual machines, network topologies, storage allocations, and other resources. When applied consistently, it ensures that environments in different regions or accounts are identical, which is critical for maintaining compliance and simplifying troubleshooting. It also supports horizontal scalability by automating the deployment of additional instances when demand increases. This capability makes IAC a foundational element in cloud network design and responsive infrastructure management. Version control integration is a key feature of effective IAC workflows. Configuration files are stored in repositories such as GitHub or GitLab, where they can be managed like any other software code. This integration supports auditing, change tracking, and rollback. Teams can use pull requests, branch protection, and code reviews to maintain quality and prevent unauthorized changes. By using version control, infrastructure becomes collaborative, traceable, and governed by the same rules that manage application code. Infrastructure as code often works alongside configuration management tools such as Puppet, Chef, or SaltStack. While IAC defines how systems should be provisioned, Configuration management tools ensure that those systems maintain their intended state over time. They monitor for configuration drift and can automatically correct changes that deviate from the defined settings. This collaboration between provisioning and state management supports long-term stability and reliability in complex environments, especially where uptime and consistency are critical. Security is an important consideration when adopting infrastructure as code. Sensitive data such as passwords, API keys, or encryption secrets should never be hard-coded in plain text. Instead, secrets should be encrypted or stored in secure vaults and accessed at runtime. Configuration files should be scanned for exposed credentials before deployment, and change reviews should include a security check. Misconfigured infrastructure can expose systems to attacks, so security must be part of every step in the IAC workflow to reduce risks and ensure compliance. Testing and validation are crucial steps in the infrastructure as code pipeline. Teams should use dry runs, also called plan or preview operations, to simulate what changes the code will make before applying them. Test environments should be used to validate configurations and catch any errors before they reach production. Syntax validation, dependency checks, and logic testing help ensure the code will perform as expected. These safeguards prevent costly mistakes, reduce rework, and build confidence in automated deployments. For more cyber content and books, please check out cyberauthor.me. Also, there are other podcasts on cybersecurity and more at baremetalcyber.com. Infrastructure as code plays a critical role in continuous integration and continuous deployment pipelines, often referred to as CI/CD. These pipelines are automated workflows that integrate code changes, test them, and deploy them into production environments. Infrastructure as code fits into this model by automatically provisioning or updating infrastructure alongside application deployments. When new software is released, the pipeline can simultaneously update virtual machines, load balancers, or network configurations, ensuring the environment is always aligned with the application's needs. This integration speeds up release cycles and reduces the need for manual intervention. Infrastructure templating is another benefit that comes with adopting infrastructure as code. Templates are pre-built code modules or configuration files that define common infrastructure components. Teams can reuse these templates across multiple projects to ensure consistent patterns in deployment. For example, a team may use the same web server template across development, staging, and production environments. This templated approach reduces duplication, increases efficiency, and standardizes architecture across teams, departments, or even entire organizations. Infrastructure as code also strengthens disaster recovery strategies by enabling rapid rebuilding of infrastructure environments. Since infrastructure is defined in code, organizations can store these configuration files off-site or in version-controlled repositories. In the event of a system failure or data center outage, the entire infrastructure can be recreated from scratch by simply reapplying the templates. This drastically reduces recovery time objectives and eliminates the need to manually rebuild complex environments under pressure. The visibility and documentation benefits of infrastructure as code should not be overlooked. Each configuration file serves as live documentation of the environment, making it easier for teams to understand the current state of infrastructure at any time. Unlike handwritten documentation, which can become outdated or incomplete, infrastructure as code reflects the exact configuration used in production. This visibility supports auditing, knowledge sharing, and onboarding, ensuring that all team members have access to accurate and current environment details. Network automation is another area where infrastructure as code is gaining traction. Traditionally, network devices such as routers, switches, and firewalls have been configured manually via command line interfaces. Infrastructure as code allows administrators to define network configurations in reusable scripts and push changes to multiple devices simultaneously. This not only speeds up deployment, but also ensures that configurations are consistent across the environment. For example, firewall rules or VLAN assignments can be standardized and deployed as part of a single versioned file. Despite its advantages, adopting infrastructure as code does come with challenges. One major hurdle is the requirement for scripting or programming knowledge, which not all infrastructure teams may have. Writing and maintaining infrastructure code requires familiarity with languages such as YAML, JSON, or HCL, depending on the tool being used. Additionally, a misconfigured script or incorrect setting in a template can have widespread consequences, potentially taking down an entire environment. This makes code reviews and testing essential practices for any team adopting IAC. Role-based access control is a critical feature in infrastructure as code environments. It defines who can read, modify, or deploy configuration files and helps enforce security boundaries within the team. Sensitive variables such as private keys, passwords, or database credentials should be protected and accessed only by authorized users. Role-based access ensures that only qualified personnel can make changes, reducing the risk of accidental or malicious modifications. In regulated environments, this also supports compliance with industry standards and audit requirements. The Network Plus exam includes questions that assess your understanding of infrastructure as code tools, workflows, and best practices. You may be asked to identify tools like Terraform, Ansible, or CloudFormation and explain their function. Other questions may focus on benefits such as version control, repeatability, or security integration. Some scenarios may present a problem and ask how automation can resolve it, or how testing and rollback strategies should be implemented in code-based deployments. Infrastructure as code enables the automation of system deployment, configuration, and scaling using version-controlled code. It provides a reliable and repeatable method for managing infrastructure in cloud and hybrid environments, with benefits such as faster provisioning, improved documentation, enhanced disaster recovery, and integration with DevOps pipelines. Infrastructure as code is a cornerstone of modern network and system management. Mastering this topic prepares you for emerging technologies covered on the exam and equips you to support scalable, automated infrastructure in real-world roles. Thank you for listening to this episode of the Network Plus Prepcast, your trusted audio guide to the CompTIA Network Plus certification. This episode was produced by baremetalcyber.com. For more cybersecurity podcasts, books, and resources, visit baremetalcyber.com. Thanks for joining us for this episode of the Bare Metal Cyber Security Plus podcast. For more episodes, tools, and study support, visit us at baremetalcyber.com. And before you take the test, make sure to check out the practice questions in the book Achieve CompTIA Security Plus SY0-701 Exam Success by Dr. Jason Edwards. They cover every domain and are a powerful way to lock in your knowledge.